lim and y lim. These are the two different methods. So the above command plt.axis, you can also convert by using plt.x limit. Then within the list only two values will be appearing, and plt.y limit, again for y limits you can specify. So I'm copying this also, these two lines. So what you can do, rest of the code is same. So only these two lines you can check it out. So either you specify using plt.axis, and if you are interested in setting individually the limits for x axis and y axis, you can set it by using plt.x lim, plt.y lim. These two different methods can also be used. So you can observe the difference. The limits are between 0 and 2. And similarly on the x-axis, it is between 0 and 8. So next thing that we are going to do here is, it is all about adding the legend. So sometimes it is quite confusing to us that which line represents which function. Like there is one blue line visible here, one orange, one green, and one red. So there are total 4 plots here. But by looking at this particular plot, no one can tell that which line is representing which particular plot. So we can show graphs so that you can identify which particular information is represented by which color line. So I'm going to make use of this complete, so that you can just include line over here. First plot in this, then this is just like an add-on. So if I keep on adding all the essential characteristics within the plot command, it will become a very lengthy line, very lengthy command. So you can split up all the settings separately, plt.legend. So this is going to be an add-on in your graph area. So I want to show over here, this is a list basically within the parenthesis. X square, x cube, I want to write 2 raised to power x, I want to write 2 raised to 2 into x and 2 raised to power x. These 4 things I want to show in the legend table. plt.grid true. Some function or things are optional. If you don't want to show the grid, you can just remove this line or make it a comment. plt.x label. So in the above example, we have not mentioned any labels for your x-axis, y-axis, and even for the graph title. So these all things can also be set separately. So in this particular code, I am using plt.x label. plt.x label, we are displaying here x equals to np.a range within bracket 3, right? So how we are getting the values of x, this we are displaying, or any other relevant x label you can choose, right? Simply x also you can write rather than this long command. Then plt.x limits from 0 to 2, plt.y label, in which we are going to write y equals to f of x. It means whatsoever values I'm displaying on the y-axis, this is achieved from f of x function that is taking x as a input. Then plt.y limit from 0 to 8, and plt.title. This method is used to display the title for your graph. So we have learned here 4 new things: how to represent your legend table, how to add the x label, how to add the y label, and how to add the title of the graph. Okay, participants. So let me copy this complete. So there are only some changes from the above code. So either you make changes in the above code, or after importing the libraries, you run it completely. Before this code, you will have to import a NumPy library and matplotlib.plyplot as PLT. These two essential libraries you need before running this code. So I have copied this code in the chat window along with legend command and X label, Y label, and title command. So I'm giving you 2 minutes. You can please check it out whether it is working or not. Very good, Mr. Ramesh. Other center coordinators can also check for the same. And in case if you have got the output, so it's a learning that how we can improve upon the graphical representation. So if your graph is not having all these elements, it means you are plotting the graph, but it is not self-sufficient for others to understand. So in order to make it effective graph, you will have to add all these things so that other person should easily interpret the graph. So now we are moving on to the next part. Very good. CT Institute also give response for the same. So this is the output of this above, where a legend table is added. So this is by default coming at the top left corner. So, but there is an attribute called location, LOC, in which you can mention the location of this particular legend. So I'm just highlighting the line which I want to just show you. This one, plt.legend command. Rest of the things are same, you can keep it as it is. So if you want to try, you can change the location of the legend table. LOC equals to lower center, right now it is coming by default at the left top. So top, now it is lower center, so location is set to this. So you can see that it will change its position, right? In the center it is visible. Bottom, you can take it as at the bottom, in the center. So in this manner, you can change the location of the legend, but preferably either we keep it in bottom right corner or top left corner. So that is preferable, because right now it is even hiding the graph. So generally we prefer either on the top left corner or bottom right corner. I hope till this point it is clear. So now next new point that we are going to add is, please run this single command whatsoever plot, because many times whatsoever graph we are generating here, I want to include it in my research report, right? Or any kind of document, research paper. So for this purpose, what you can do, you can run this command after your code that you have just seen. I'm typing here in chat window, it is there, plt.savefigure. plt.savefigure. So by including this command below, so what you will get, this complete graph will be saved to the directory. So as I have not mentioned any absolute path, so by default where it will go, please tell the answer. Where test.png will be saved? Type here in the chat window. Where your graph output will be saved. Very good, in the current directory. And have you people checked what is the current directory at your machine? Yes, participants, have you checked till now where your programs of Python, Jupyter Notebook are getting stored? In case if you wish, it should be saved in some other project folder or so. So you will have to explicitly mention, right? So otherwise, by default, when I am not mentioning any path, it will be saved to the root directory where Python Anaconda is installed. Is participants, next is our graph, that is bar plot. We are going to draw this bar plot over here. So in order to draw the bar plot, I need two inputs. The first input that I'm referring to is X, which is a list. So you can specify list of values. Then you can have Y, which is another input. Again, it is in the form of list. So I have mentioned this list of values. 5 values in X list and 5 values in the Y list. Then make use of plt.bar command X comma Y, and then plt.show. So after running this code, you will get this kind of bar plot, right? So And this is another way of taking this matplotlib library. From matplotlib, import pyplot as plt. This is the second sentence. Either you do import matplotlib dot pyplot as plt, or you can also write from matplotlib import pyplot as plt. So these are the two ways of importing the specific methods or libraries in a hierarchy. The code is pasted here in the chat window. You can run, and one line I have made a comment, that is plt.scatter. So scatter plot also you can plot. Scatter plot is nothing but it will simply show the circular dots, right? For every respective data point in your data set, it will just show a dot. So if you uncomment this line, you can also check for scatter plot. For that, we have method plt.scatter x comma y. These are the two values, right? So I have made it a comment because at the same time, if I will plot, then it will just merge the output of these two commands, two plots above. So in order to avoid this, I have just run one command plt.bar. So now what you can do, you can see plt.bar will be made comment, and you can uncomment plt.scatter command in order to see the output. So usually we want to draw a plot which student or which roll number has secured maximum marks. So bar plot is an efficient way of representing such kind of thing. I have represented marks achieved by the 4 students respectively. First roll number 90, second roll number 89, third roll number 73, fourth roll number 59. So what you can do here is plt.x level we have set to roll number, plt.y level is marks, plt.x we have mentioned because the values are ranging from 1 to 4. So the range 0 to 6 is sufficient, and the marks are ranging from 0 to 100. So the y-axis limit I have also mentioned here, then plt.bar command. So it will just display this bar plot for the marks of students. Very good. So those who are doing, it's very nice that you people are at least trying along with me. So this is a small example where practically you people may need to draw bar plots. So for this kind of task, you can make use of bar plots. So next we are going to do a pie chart over here. Pie chart. In order to draw a pie chart, as you know that pie chart works on a single column data, and for that particular data you need to show, let's say, some kind of label as well. Like you want to show some data with respect to these different categories of cars: Audi, BMW, Ford, Tesla, Jaguar and Mercedes. Corresponding to this, the data that I want to use is 23, 17, 35, 29, 12, 41. So could you please tell what is that total of this? What is the total of this? So after assigning the values to the two variables cars and data, we are going to create a pie plot over here, and for that we will make use of the command plt.figure. Figure size equals to 10, 7. So this is basically the figure that we are plotting. So you can also reduce or increase the plotting area. You can see the size of this pie chart. So this is being done with the help of figure size. If you will reduce it, let's say I will make it 8, 5. So it will reduce the size of this. Can you see here? What is the difference? The size of the pie chart is reduced. So I am simply mentioning the size of the figure that I am drawing here. Figure size equals to 8, 5. So then plt.py. So in plt, we are having a py command, plt.py, and to this we are passing this data in the form of list, comma, labels I am taking from the car variable. So in a pie chart, every sector is representing one particular type of car. BMW, it is taking its data from the data which is mentioned above, and similarly rest of the others also. So you can take up anything. Let's say in place of this, you can show some other data as well. This is about cars. You can take this about, different states. What is the literacy level in different states? So could you please show me the code? What you will write? Yes, participants. I am pasting this code over here for pie chart. So could you please try it for how to represent the literacy rate in 5 states? Take any 5 states and you will have to represent the literacy rate. What changes you will made in this? First run it on your machine and then copy the code here in the chat window, those who are able to. Done. I hope the query is clear to you. You will have to create a pie plot with respect to the literacy rate in 5 different states in India. So after executing, type your response here in the chat window so that I can see which remote center is able to do. Take 5 minutes and paste your response here. Okay, I got one response. Pankaj has done. Pankaj, could you please copy? Alternate method. I'm interested in knowing how you have displayed the pie chart for the 5 states literacy rate representation, for representation of literacy rate in the 5 states. What change you will make to the above code which I have shared with you? Okay. So Mr. Ramesh has done. So he has created. Let me copy Mr. Ramesh output in order to show you people what he has done. Very good, Mr. Ramesh. So he has modified the code. In place of car, states will come. So it means we are having these 5 states, and corresponding to this, we want to show some literacy rate, right? So the data he has mentioned in the data list, and here you just need to take in place of labels equals to cars, labels equals to states. Rest of the things are same. So in this manner, you can customize the pie plot depending upon your requirement. Now we are going to learn how we can play around the characteristics of these plots in addition to labels and titles, grids and axes. These 4 things we have already seen: how we can plot a graph, how we can make changes with respect to the type of plot, with respect to x and y labels, x-axis and y-axis limits, and we have also seen how to add the legend, how to add the title of the graph. Now let us see how some more changes we can apply. So in this particular plot, we are going to show these multiple plots. You can see here these multiple lines are coming because of these different plots. PLT dot plot x comma y plus 1, x comma y plus 0.5. So different plot functions we are mentioning just in order to vary the color. The only thing is, if I will not provide these colors along with these plots, it will take by default. So if particularly you want to show that this particular plot should come in green, this should come in Y, that is yellow, red, green, yellow, C for cyan, K for black, M for magenta, W for white, and B for blue. I hope RGB, CMYK. These abbreviations are known to you. Red, green, blue, cyan, magenta, yellow, and black, right? So all this stuff you can represent by changing the color. So within single quotes, this is the color representation. Rest of the commands are known to you, plt dot plot. So you can specify the color. So this is just the comprehensive way of above. So above you can represent using this single command also. I have just integrated all the plot commands in a single plot command. So you can run it. I'm pasting this code here. So all the different plots. It means when it comes to customization, if you know how to do the things, you can do as per your choice. And if not, then by default, whatsoever system allows to represent, that you will have to accept. So in data visualization part in languages like Python and R, we are having very different capabilities available. You can play around with all the possible characteristics. So that is the advantage of using these languages. So you can represent your graph and plots very effectively. So after this, you can run it. I have copied in the chat window this particular code. Now the next is, now we have seen that there is a possibility to change or customize the color on our own as per our requirement. So can I make changes in style as well? So you can see here that x comma y, this is the first plot that I'm interested in plotting. It should be shown by using dash. Then x comma y plus 1, it should be shown using next, that is double dash, right? Then dash dot, and then the last one colon. So it means you can represent with the help of different, these are also known as marker styles. So these are the marker styles which we are using in order to just represent the lines that we are interested in plotting. So you can also run any command by using the plot, where two values are representing x comma y for plotting, and this dash or dot is representing the style. So along with color, you can set this also. And here comes the combination of two. You can see here that in the single command, I have mentioned O. M represents the style, right? So this mauve color and this O represent this circular symbol. Are you able to see these 5 data points are represented using circle? So this is because of this. So you need to understand M is for color, O is for this circular mark, and dash dash is for the connecting line. Similarly, the another plot which you are having, x comma y plus 1. In this, I'm giving which are displayed these dash dot next to a dash dot. So you can see here that the stars are connected by dash dot dash dot. This kind of PLT is quite interesting, means there are several ways. You are not limited by just one way. There are several ways. The way you know, you can modify your graph. So I'm pasting it here. You can try this. M stands for, again, the color of the line, then the marker style, and then the line styles. 3 things in this brief coding I have clubbed. So in plt.plot, you can mention all this stuff, that this plot should be shown in this kind of color line, this kind of marker style, and this kind of connecting line. So all this you can provide simply in the compact manner. So I hope you are able to do it. So you can add, but you will have to try. I am writing here one command that you can try later on. Add dot text. So you can add the text additionally. So in a PLT, you have a text command also. In this, you will have to pass the arguments in order to means display the values. Yes, participants, have you tried the code? So next is plt.plot, in which we are going to add some more characteristics like x comma y is the plot that we are trying to plot. Color equals to green. Now you can see here that I'm showing the attribute names which we were setting earlier. So G was basically color. Color equals to green. Line style equals to dash dash. Line width also you can mention 1.5 we are taking. Marker style. So caret symbol or star symbol you can mention that you are interested in. Marker face color. So actually if I will increase the plot size, then you will be able to see what I am going to refer here. Just try to observe this inside this triangular marker, the color is blue and the color of the edges of this marker is black. So this is marker face, right? There are two different properties that you can set for this. One is marker face color, another is marker edge color. So let me reduce the size. You can see the code then. So I hope now it is understood what do we mean by marker face color, which is blue visible to you, and marker edge color means marker boundary is basically of black color. Marker edge width, the edge that you are showing. So if I will make changes, let's say 2.5, so it will just enhance. Can you see here? By making it 2.5, the marker edge is increased. So, and marker size is currently selected as 5. If you will make it 7, then it will increase further the marker size. I hope it is visible to all of you. So in this manner, you can make variations. So you are having different properties. So I'm giving you 2 minutes. Please run this and make changes as per your requirement. You can see the effect of means which property is affecting. Run it at your end. All these properties you can vary. You can change the different colors. line styles, line width, marker face, marker edge color, and so on. All these properties you can vary. So I have converted it to star. So star also you can show. So there are different ways in which you can modify. Another way to specify here is each individual attribute also, as we have seen above, line style. Either you type this name of the style, that is solid, dashed, dash dot, dotted, or simply another way, simply mention. Solid means this, dashed means double dash you will have to represent, dash dot means one dash and one dot. So now you can interpret that earlier we have used in many of the plot commands all this kind of representation in single quote. So these were equivalent to the line styles. So there are different ways to represent the same. Either you can type the complete name of the style, or you can simply show it how it will appear in the graph plotting. Similarly for color as well. So in this particular graph, what we are showing here, these different plots are represented, and this is with respect to all these functions. I am taking a plot between x and np, that is numpy library dot sign method, and we are passing this as an argument, and color is blue. So you can see here is, if you mention the color completely, you will have to write blue, and if you will simply write b only, it will work. So these are the different type of color settings, right? First one is complete color specification by name. Second is abbreviation of color name. So color coding can be done as per RGB, CMYK. All these values you can set in color. And then I can also mention values between 0 and 1 for the color. And then hexadecimal representation, all of you know that hexadecimal representation can also be done. You can see the hexadecimal color coding chart, and accordingly you can choose the color. And the next is RGB tuple. The first value between 0 and 0 and 1 with respect to R. The second between 0 and 1 for the green, and the third is value for blue between 0 and 1. So the minimum value for color is 0 and maximum is 1. 0 represents black and 1 represents white. And the third, last one is color equals to HTML color names. So all these are supported styles. So the way you feel comfortable, accordingly you can mention the properties. So we have covered mostly all the properties. So one more example, as in NumPy, there is a way to describe this linear space method is there, in which you can take the consecutive values or with some gap using the single method. So this also you can try. One more example I'm copying in the chat window. X equals to np dot linear space 0, 10, 30 means it will start from 0. It will generate the values, 30 values between 0 and 10. Are you getting me? Starting value 0, ending value 10, and in between 0 to 10 range, it will create 30 data points. And these data points I'm passing to sign function as an argument. And then we are plotting by using the black color. So find this code here in the chat window and you can simply run. This linear space method is available to you in the NumPy library. Those who are able to do, please give your response in the chat window so that we can proceed further. In the last few minutes, I would like to introduce one more visualization library. So in your free time, you can try out for all possible, because I'm not telling you all the possible settings. For colors, we have tried to cover like the line styles. Can you see here in this graph? We are using dash and P. P is for this polygon. Are you getting this? The style of the line is dash P. Dash P stands for polygon. Dash and then polygon marker. Color is gray for this marker. Marker size is 15. Line width we are taking 4. Marker face color is blue. So you can try as per library in different settings you can do. So now we are moving on to how we can represent. So this is not particular to social network, but with respect to any kind of graph, you can take any kind of nodes and edges you can represent. So for this, we are having network X library available, and in this also we need to plot by using matplotlib library. You can add the nodes by using the command g.addNode 1, 2, 3. Like I have taken these 6 nodes. It means I'm creating graph first of all. I will tell you other ways also through which you can easily mention all these things. And before this, we will have to create an instance of the graph. I'm going to show the diagram. So network X is having its, alias name, which I have created above is NX. It's a network X library alias name, NX.diagraph. All these nodes I want to show. By using add_node method, I can add. And then I'm moving on to, these are the list of nodes if you want to see. G.nodes you can represent all the nodes available. And then similarly, we are having a method g.add_edge. These are the edges, 1 to 2, 1 to 3, 1 to 4, 2 to 3, and so on. So all the edges that we are interested in, we can show. And then we are showing here nx.draw method. Nx.draw, we want to represent this graph with labels equals to true and node color equals to red, right? So till this point means we are able to show means how the graph will be appearing. So can you see here the plot of this graph will be like this, right? So all the nodes are appearing in the graph in red color, labels are visible to us, and it is a digraph, means directed graph. So if I will simply write nx.graph, then these arrows will not be visible. So in this manner, you can create a graph using the NetworkX library. A few more examples I can show you in order to make you clear. Like in this graph, can you see here we have drawn one more graph. So these kind of all variation you can do. So you can run this one complete graph. For this, you need to just run these 3 lines or in order to draw a complete graph. Import NetworkX as NX, import matplotlib.pyplot as PLT, Z equals to NX.complete graph. So if you want to simply show a complete graph, it's very easy in NetworkX. Just run the method complete underscore graph and specify the number of nodes. So it will just create before you the complete graph for the same. So you can see here that this is the complete graph, right? This is the complete graph. And after mentioning these 3 lines, you will have to draw the graph. So these 2 more lines will be required. So nx.draw and plt.show. So after running the above 3 lines, 2 more lines you will have to add in the code. nx.draw with underscore labels equals to true. If you will not set this attribute with underscore labels equals to true, it will not show the node labels. That will be the difference. So without the node labels, it will show you the graph. So currently this is our complete graph. So if I will increase the number of, nodes here, number of these nodes value, so it will draw a complete graph for 20. Can you see here? I hope the graph is visible. So for 20, this is the complete graph. So in this manner, you can visualize your graph. So the whole game is all about how to represent your nodes and edges and their connectivity. So accordingly, you can plot a graph. So it is having many methods through which you can create a graph randomly also. Like we are creating here one random graph which is going to have 20 nodes and the probability of connectivity between the nodes is 0.5. So half probability is there that the 2 nodes will be connected. So it's a very good random graph where you can change the probability and you can see the number of edges will be increased or decreased according to the probability. So this is a graph between the 20 nodes and the probability is set to 0.5. So if I will reduce the probability of connectivity, let's say I'm only giving 0.3. So again, I'm running this for you. Can you see here the sparse, the graph has become now little bit sparse. The number of edges are reduced. So in the 20 nodes, it is not going to be a strongly connected graph because the connectivity probability I have reduced. So for every pair of nodes only, these many percentage of nodes means 0.3% probability is there that the edge will be connected. Again, I have reduced this to 0.2. So further, it will show you less number of edge connectivity. Just see this graph. So it will keep on reducing this number of edges. Okay. So can you see here? It is a city graph. So you can show the network connectivity by using this NetworkX library. You can also show the connectivity between the cities. You can show a road network, railway network, molecular network, any kind of network which is represented by using the concept of graphs can be represented using this. Fine, participants. So this example I am just adding for your reference. You can see the output and you can make the changes. So we are basically modeling a road network of some cities. So it all depends which edges you have shown as connected. I'm pasting it here. So in this, I have utilized one more, attribute node size. So you can increase or decrease the node size. So now your whole representation is by using the nodes and edges. So this last example, you can just try out, in which we are going to, draw the graph. So I have just included few examples. So it is basically an area of network science, and you can work upon complex network analysis. So any kind of thing that you feel that it can be represented using graph. So it is very helpful for representing your fundamentals with respect to graph theory also. So nowadays people are working on smart city projects or another available. Depending upon your requirement, you can explore and you can analyze. But Python also supports a network X library for the graph based data analysis. So participants, with these words from my end, it is over. If you have any query, you may please ask. So for today, having time 20
Definitely, ma'am.
give us, so we wind up